Hey everyone, I'm Mark Tong. I am now a 12th grade student who has previously studied in the IGCSE 0606 CIE math back in 9th and 10th grade. So now in this series of videos, I'll be breaking down some math concepts into simple terms and hopefully help you guys to master the necessary knowledge along the way. In this video, we'll be starting with functions, which is now the first unit of the new 0606 syllabus, as the old text and Venn diagram unit is now removed. And let's get straight to it. So basically, start with a function is basically denoted as f parentheses x, and for each x value, you'll get only one y value. So fx equals to f parentheses x you will obtain a y value. And now we have and before we actually start with function itself, let's identify what is a function and what is actually not. And there are different type of functions shown here. So we have one-to-one mapping, which is for each x value you get one y value. Many-to-one mapping, which means for many y value. For many x value, you get only one y value, and one-to-many mapping, which means for one x value, you get many y value, and many-to-many mapping, which means for many x value, you get many y value. A one-to-one mapping can look like a straight line, where one x value will only map to one y value, and vice versa. For instance, as you see here, y equals to 3x plus 1. And this is a linear function. And for each value of x, you're going to get one. For each value of x, you can only get a same value of y. For instance, if y is 4, then 3x will be equal to 3, and x can only be equal to 1, and there's no other value that can be consistent in this equation. And many-to-one mapping, as shown, that's basically where one y value can be mapped with two different x values, like we have in this quadratic graph right here. When y equals to 9, you obtain two different x values, 3 and minus 3. So it is a function as there's the same y coordinate for both x value. For one-to-many mapping, you can see from the example right here. For each different value of x, you may obtain 3 different values of y. This is not a function as there is 3 different y values. And for many-to-many mapping, as you may see here as a circle, for multiple values of x, you can get multiple y values. For multiple x, you can get a multiple y value, and that was also not a function as well. And now we continue to basics on the function notation. So for this function, let's see how to notate it first. So this means that for f, it's such as x is mapped onto 2x plus 3, which means for the value of x given in the equation, a value of y will be obtained for a given value of x. So you see here, for when x equals to 2, you input 2 in the equation, 2 times 2 plus 3 equals to 7, and the point here is 2, 7 when x is 2. When x is minus 4, given in the equation, 2 times minus 4 is 8, 8 plus 3 is minus 5, and for when x equals to minus 4, y equals to minus 5. Same for gx. If gx equals to a function g has an x value, has a function g have a special y value for a given value of x, then you input the given x value in the equation, and you obtain the y value for a given function g, which is the same logic as the function f. And now for these kind of questions, if the value of x is now changed into for this instance, x is changes to minus x, then you input the what should be an x as a minus x, and continue the equation as usual. For minus and minus will be equals to plus, so it's 5 plus x instead of 5 minus x, and for minus x squared, it's equal to x squared. So the function still stays the same as minus x squared. So it's the final equation you obtain is 5 plus x minus x squared. And for domain range, so domain is the set of x values that may be obtained in this equation, and the range is a kind of relation with a set of y values that can be used in the relation. Look at examples. You see, for this example, the function has started from -1 x is -1, y is -3, and then moves upwards without an n value. So for the domain, which is the x value, it will be the lowest is -1. So and x is and with this trend, x will keep increase. So the domain is now x minus x as equals to or largest to -1. So for y value, the lowest y value, the y minimum is -3, and looking at this trend, y will keep increase forward. So the range will be y larger than or equals to -3 without an ending point. Look at the second example. This is a quadratic function with a parabola. The vertex point is 2, 1, x is 2, y is 1, and the domain. And look at the domain first. There is an infinity of the x value because, as you can see, there is. So on both two sides of the equation, the x can still keep increase and decrease for whatever given value and obtain a value of y. So the domain is x will equal to r, and this means that x can equal to any real number. But look at y. The maximum point of y is 1, and below 1, y will keep on decreasing, but y will not exceed 1. So the range is y equals to or smaller than 1. And now we look at these type of equations. So with an asymptote in the middle, an asymptote means that the x or y value will be infinite close to this value, but will never equal. So you see from this instance, look at the domains first. The x asymptote is 2, the y asymptote is 1. So when there's below 2, for below and greater than 2, the shape of the function will change. But any x value may still apply in this equation except the asymptote. So the domain is x not equal to 2, as any other values may stand in this equation. The y asymptote is 1, so for any y values other than 1, as you see, y can still keep decreasing and still keep increasing. So the range of y is y not equal to 1, as any other y values may stand. So now we look at the modulus function. With the modulus, which is basically the absolute value of the function, which means that you only recognize the real number and ignoring its positive or negative sign. So, for instance, when you see the x is given to -3, however, when you put the modulus in it, you ignore the sign on front and you only recognize your real number. So x with the modulus of x in this case will be equal to 3. And look at another case for the modulus of x squared plus x. First of all, you finish the equation. You input the value here first before completing the modulus. So as x is given -3, you squared -3. X minus 3 squared is 9. 9 plus -3 is -6. Is positive 6. And for the positive 6, the modulus is 6. Now, look at this equation right here. For the modulus of 7x plus -1 divided by 2. You finish the equation first. You finish everything inside the modulus first. So when x equals to -3, 7 times -3 is 21. 21 minus 1 is -22. -21 divided by 2 is minus 11. However, for modulus, you ignore the sign up front and only obtain real number. So the answer is 11. And now we look at some composite function, which is more trickier than what you may see before, as it combines combines different functions together right now. So when the composite function, which means that you basically add two functions are added together, and the value will keep going on. For example, you will see if the x value for the function will be decided on the final y value that is obtained in the gx function. And this will also have different notations, such as I'd like to abbreviate this as fog, which is easy to remember, which is with a circle in the middle, and x parentheses as itself, and as fgx, which they are actually the same. And first of all, a good example could be this: when x and the function for x is x for the square root of 4, and gx is 2x plus 3. So in this equation, it is given for you to obtain the fog x. Fog x means that the g will convert to x to 2x plus 3 to 2x plus 3 first, and then the f will convert the value that gx converted into the final value. With a simple diagram right here, when you input x, you double it given by the function, and then you add 3, and the final value is 2x plus 3 for this equation. So when you are getting the fog x, meaning you use the gx value as an x in the f function. So the 2x plus 3 is now the x value of the function. You raise the number to the power of 4, and then in the end you obtain a 2x plus 3 with the power of 4. So fog x equals to 2x plus 3 with the power of 4. Same time, if the x value in the g equation are determined by the x value obtained at the f function, for example, when x value is for x value in function f, you get x with the power of 4. So for the gx function, the original x is now substituted as the x with the square of 4. So the g with this, so g with x4 squared will equal to 2 times x with the square with the power of 4, and plus 3. However, sometimes the notations may be similar, but the sequence it's very important. So if you do it in reverse, the functions may not be the same. Such as you may see so for fog x, you get 2x plus 3 minus 4, but for the golf x, you get 2x with square 2 times x with a power of 4 plus 3. So you see, so even though they look kind of similar and looks only the sequence has changed, but in the final value obtained may be substantially different, and they don't equal together. And also, when you see f of fx, it means that the x value of the value of you obtained in f, and the fx will be done again, but it does not equal to squaring the values of f, the values that you obtained at fx. They are completely different. Look at this example. The f of x equals to 2x plus 1, and the g of x equals to 3 minus 4x. When you're calculating the fog x, it's best you change it into simple notation. So f parentheses with the inside of gx, and the gx is 3 minus 4x. You substitute gx with the given value, with the given equation. So now it's the f with the x of 3 minus with a new value of 3 minus 4x, and you input it in the fx equation, which means that 2 times parentheses 3 minus 4x plus 1. You break it. 2 times 3 is 6. 2 minus 4x is 8x. And in u plus 1, 6 plus 1 is 7. So the final value obtained is 7 minus 8x. For the gfx, you change it to a simple notation first to help you to not make confusions in the middle. So the fx value is 2x plus 1. You input the equation here as substitute the value is substituted, and now g and the value of the new value of y for the g functions will be obtained based on the 2x plus 1 value of x. You input in the equation of 3 minus 4x and the function of gx, so it equals to 3 minus 4 with the parentheses of 2x plus 1. You break the parentheses down, which equals to 3 minus 2 times 4x is 8x, and 1 times minus 4 is minus 4. 3 plus minus 4 is minus 1, and the final equation obtained is minus 8x minus 1. And now we're looking at sign diagrams. Sign diagrams is a scenario which can help you to see the value of the actual value of y when x is larger or below a certain value. For instance, looking at this function, y equals to parentheses x plus 2 and parentheses x minus 1. So we look at the zeros first. So when x equals to minus 2, it's 0, and when x equals to 1, the y value is 0. So you input the two zeros here. If you want to identify the trend of the function, you can input any value below minus 2 to see whether the functions will be positive or negative. So for instance, I'm going for minus 3, and minus 3 plus 2 is minus 1. Minus 3 minus 1 is minus 4, and you times the two parentheses together. Minus 1 times minus 4 is it's positive 4. So the sign diagram of any value below minus 2 is positive. And now you test the range between minus 2 and 1. So to obtain, the simplest way is to get x equals to 0. So the function will be minus 1 times 2, x will, and the y value will be minus 2. As minus 2 is below 0, the sign diagram will come out as negative. And now looking at the values more than 1. For example, our goal is 2, but any value greater than 1 will have a similar trend in this equation. And when x equals to 2, 2 plus 2 is 4, 2 minus 1 is 1, 1 times 4 is 4, 4 is larger than 0, so it's positive, so the trend of the sign diagram is positive. Now we look at another center function, minus 2 times with the square minus y equals to minus 2 times x minus 1 squared. It's very easy in multiplication, if one of the values equals to 0, the whole function is equal to 0 as well. And so it's very easy to identify that x can only be 1. As 1 minus 1 is 0, 0 times minus 2 is 0 as well. So now we look at values. So now at 1 is the 0, and now we need to look at values more than 1 and below 1. As the same thing, any value below 1 is fine, any value more than 1 is fine, as the trend will be the same. So for instance, when x equals to 0, 0 minus 1 is minus 1, minus 1 squared is 1, 1 times minus 2 is minus 2. Minus 2 is below 0, so the sign diagram will come out as negative. For x more than 1, for instance, x equals to 2, 2 minus 1 is 1, 1 squared is 1 as well, 1 minus 2 is minus 2. And minus 2 is below 0, so the function will come out as negative. So this is the final sign diagram for any value, so value below 1 or negative or below 1. For x, a value below 1 or more than 1. the y value will always be negative. And you can also determine the sign diagram by just looking at the function itself as the upper part of functions will means that y is smaller than 0, and the functions values below the x-axis will indicate that y is negative. So you can just simply draw the sign diagram based on the zeros given: -2, 0, 1, and 4. For any x values below -2, you see that y is below the x-axis, so the sign diagram, the sign is negative. So for any values between -2 and 1, the value will come out as positive because the area here is more than is on the upper part of the x-axis. It's higher than the x-axis, so the sign is positive. For between 1 and 4, the area here is below the x-axis again, so the sign diagram will be negative. For values of x more than 4, the y value will always be on top of the x-axis, so the sign diagram will come out as positive. With the power of -1, parentheses x just for clarification, it does not equal to f with the power of -1x, because this is just a way of notating function not actually the reciprocal of f. So it does not equal to 1 over fx. And what is the inverse function? What is f minus 1? As f minus 1 is a reflection of the original function using the line y equals to x, which is the identity function, as it changes the identity of the original function. This name. And now let's look at a few examples on what is inverse function actually. So for the original function, when you are inputting the value of x, for instance, for the equation of y equals to 2x plus 3, the x value is 4, and in the output you will get a y equals to 11. And now for the inverse function, the output of the inverse function should be the input of the original function. So the output of the y equals to 2x plus 3, the original function, is now the input of the inverse function. The inverse function is y equal to x minus 3 and have everything divided by 2. So when the input is 11, 11 minus 3 is 8. 8 divided by 2 is 4. 4 is the output, and is also the input of the original equation. So as the output, the output of the inverse is equal to the input of the original function, and the input of the inverse function is equal to the output of the original function. Y equals to x minus 3 and have everything divided by 2. It's the inverse function of y equals to 2x plus 3. And now let's look at how to do it graphically. So in this case, the green line, which is the original function fx, has a domain of x between 0 and 4, and a range of y. And the range of y is y between -1 and 2, and can equal with all of them as well. And y equals to -1, and y equals to -2, and y equals to 2. So now with the identity function of y equals to x, let's see the inverse function. And now I'm going to teach another trick, as the inverse function of fx the domain of the function of fx will be the range of the new inverse function, as everything is reflected on this on the identity function, and the original range of the fx function is now going to be the new domain of the inverse function. So in this case, you see the red line, which is the reflection of the original function. The original starting point of the starting point of the original function is x equals to 0, y equals to -1. Now in the inverse function, the starting point of x is -1 and y equals to 0. So the sequence has just changed. From the example, you can see the domain of x minus 1 is equal to the range of f. The domain of f with the f minus 1 is equal to the range of f. The range of f minus 1 is equal to the domain of f. And now let's look at the other type of inverse function, the self-inverse function. So basically, self-inverse function is an inverse function that have the same inverse value, the same inverse function as the original function. For example, the function of f, the function of x with the power of minus 1, the inverse function is also y equals to x equals to 1 over x, which is the same function, and this is called the self-inverse function. And now I have some questions for you to practice, and the unit of function is now over. If you have any questions, please leave down in the comments. And if you have anything, just feel free to email me as well. My email being left there below. Thank you, Mark, and see you in the next series.